Hey guys, so today we're going to look at adding and subtracting rational expressions, and it's just the same as adding and subtracting fractions, right? So when you add and subtract fractions, we need a common denominator, and when there is a common denominator, it's nice and easy. We just add the numerator and keep the denominator the same. So for example, 2/13 plus 5/13, that would just be 7/13. And then if you can reduce the fraction, you reduce it, and if not, then that's it. So just the same, if we have variables in there, in the second example, we have 5x over 7 minus 2x over 7. Again, we have a common denominator. We're going to go ahead and subtract. So 5x minus 2x is 3x in the numerator over 7. C, we've got 5 plus 2, again 7 over 8a. And then for D, we have 4x minus 7 in the numerator, and we can't combine like terms because they are not like terms, so we'll just leave it as 4x minus 7. And then the denominator, we have 2x plus 3, and that's it. So once you add and subtract the fractions, if there is a common factor in the numerator and denominator, you can go ahead and cross them out to simplify the fraction or reduce the fraction. And if there isn't, then you just leave it as is, right? So remember that we can't just cross out these x's, even though there's one on the top, one on the bottom, because they are attached to 4x minus 7. So when we cross out common factors, there can't be any pluses and minuses between the factors. Okay, so it's nice and easy if they already have a common denominator, right? We just add the numerator or subtract the numerator and keep the denominator the same. Now let's look at a scenario when there isn't a common denominator and we have to create one. So steps of adding and subtracting rational expressions, the first thing you want to do is to factor out each denominator. Factor the denominator if possible. That's going to help you break down what the factors are so that it's easier for you to create that common factor. And then step 2, we need to create a common denominator using special ones. So we want to create a common denominator, not just any common denominator, but the least common denominator so that our numbers are not as big. All right. And then once we have a least common denominator, we're going to go ahead and add and subtract the numerator and then finally simplify if possible. So let's look at an example. In the first example, we have 5/8 minus 3 over 8x. And in this particular case, we don't have a common denominator. So when we add and subtract fractions, that's what we need. Okay, so, but it's very close, right? That first fraction, all we need is an x there. So what I'm going to do is I'm going to multiply this first fraction on the left by a special 1. And this 1 is going to be made up of x divided by x. Anything divided by itself is 1. Okay, so multiplying by 1 does not change my 5/8. However, it will allow me to rewrite it so that the denominator is the same. 5x divided by 8x is now my fraction, minus 3 over 8x. And now I have a common denominator, and I can go ahead and subtract. So in the numerator, 5x minus 3 cannot combine those, so we'll just leave it as is, over 8x. And that's my answer. Cannot reduce any further. Okay, in part B, now, again, I don't have common denominators, so I need to create one. And the first thing that we need to do is factor the denominators if possible. So if I look at the first denominator, it looks like I can take out a GCF of 4. So if I divide out a 4, and it goes in the front, it doesn't go away, I have 4 times x plus 3, okay, which looks very similar to this one right here. So the only thing that I need to do in order to create a common denominator is I gotta multiply this by a 4 because this one has a 4. So again, I'm gonna multiply by a special 1, just the second fraction, in order to create that common denominator. And in this case, my 1 is just going to be made up of 4 over 4. Okay, so I'm gonna rewrite my problem. I have 2 over 4 times x plus 3, and then plus 28 over 4 times x plus 3. Okay, and then from there, we have a common denominator, and we can go ahead and add the numerator. So I have 30 over 4 times x plus 3, and then notice that 30 over 4, I can reduce that. So if you can reduce after you add and subtract the fractions, your final answer, if you can reduce it, go ahead and reduce it, right? We can, 2 goes into 30, we can take out a factor of 2, and I'll be left with 15, and I can take out a factor of 2 from the denominator, and I'll be left with 2. So your final answer is going to be 15 over 2 times x plus 3. And I can't reduce any further. Okay, it also will be correct if you decide to multiply the denominator out to x plus 6. That would be fine as well, but you can leave it in the factored form. All right, let's look at the next one. Looking trickier, but still very similar. Step 1 is to factor out each denominator if you can. Okay, the first denominator, y plus 5, I can't break that up any further. But the second one, I can, right? So the second one is a quadratic that I'm going to try to factor. So y, and if we think of our x factor method, looking for factors that multiply to give me 10 and add to give me 7. So that's going to be 5 and 2. Okay, so this becomes y plus 5 and y plus 2. So that's my denominator. I'm going to rewrite it. 3 over y plus 5, first fraction, plus y over y plus 5 times y plus 2. All right, and so again, if I want to add the two fractions, I need a common denominator, and all I need is my first fraction already has y plus 5, right? So all it needs is a y plus 2. So again, I'm going to multiply this first fraction by a special 1 in order to create that common denominator. And my denominator needs a y plus 2. So my special 1 in this case is going to be a little bit more complicated. It's just going to be y plus 2 over y plus 2. Okay, so then we're going to go ahead and simplify. So I'm going to multiply this 3 through. It's going to be 3y plus 6 over y plus 2 times y plus 5. And then my second fraction is just y over y plus 5 times y plus 2. And now I have a common denominator. We're going to go ahead and just combine the numerator. So 3y plus 6 plus y. 3y plus y is 4y. So 4y plus 6 over y plus 2 times y plus 5. Okay, and this is my final answer. Now you could say that, well, how about in the numerator, can I factor out a 2? Yes, if we factor out a 2, what's left over is still a factor that we can't cancel out from the bottom either. So we're just going to leave it as is. This is our answer. All right, last one, trickiest one. There's nothing to factor out in the denominator. Y plus 2 is one factor and y minus 5 is another factor. And they don't have anything in common, right? So what I would have to do to create a common denominator is I would have to multiply the fraction on the left by a special 1 and the fraction on the right by a special 1. And it needs to have the same exact denominator. So since the first one already has x plus 2, I need to add that x minus 5 in. So I'm going to multiply by x minus 5 over x minus 5, and then for the second fraction, it needs the x plus 2. Okay, and so then we're going to simplify. So multiply the 7 to the x minus 5, so that's going to be 7x minus 35 over x minus 5 times x plus 2. And then minus, I'm going to distribute that 4 through, 4x plus 8 over x minus 5 times x plus 2. And now that we have a common denominator, we can go ahead and combine the numerator. And now when you do that, I want you guys to be careful, because when you're subtracting just one term, that's easy. You just subtract it, right? But here we're subtracting. Don't forget you're subtracting the 4x, and you're also subtracting the 8. So you're subtracting two things here. And I'm just going to rewrite it. That might help you so you don't mess up with the signs. 7x minus 35 minus 4x and minus 8. Okay, all over x minus 5 times x plus 2. And then we're just going to combine the numerator. Combine like terms. So 7x minus 4x gives me 3x. And then negative 35 minus 8 is going to give us negative 43 all over x minus 5, x plus 2. And that's our final answer. Cannot reduce any further. So when you're adding, subtracting fractions, you need a common denominator. If you already have a common denominator, you're good. Just combine the numerator by adding or subtracting and keep the denominator the same. If you don't have a common denominator, you need to create one by multiplying either one or both of the fractions by a special 1 in order to create a common denominator first. Once you have the common denominator, again, you can add or subtract the numerator and then finally reduce your fraction if necessary.